Okay, I'm delighted to welcome Matthew Hayes, or Matt Hayes, from the University of Cambridge, who's going to talk to us about a couple of projects and how they're woven into his research and the PhD that he's currently studying. So over to you, Matt.
Thank you very much indeed. Yes, thank you everyone for tuning in to my talk this evening. My name is Matt Hayes. I'm a PhD student in the zoology department at Cambridge University, and I'm going to be talking to you about my PhD research, but also about a public engagement project which I did at the Zoology Museum at Cambridge before the PhD, and some of my PhD has sort of expanded upon that project. And that project was called Butterflies Through Time, where we were using wildlife of the past to guide conservation of the future, but also trying to engage modern audiences with wildlife that is still around them today. So we're looking at modern conservation with an eye to the future problems of climate change, but also then looking to the past with museum specimens to tell us about some of the lessons they can teach us. So we're going to be looking at that this evening. Before I do that, though, I'm just going to briefly give you an overview of my research group. There we go. Um, so I'm a member of the Insect Ecology Research Group, and generally speaking, members of this group try to better understand the importance of invertebrates and aid their conservation as we do so. And we actually do this in quite a few different ways. So roughly half the group work out in Southeast Asia in oil palm plantations, so very far-flung places from where I work. Oil palm is the fastest growing crop in the world, and they're seeing how invertebrates can be conserved alongside growing this crop, and actually how the crop can benefit from having invertebrates around for things like pest control and pollination and things like that. So that's what one half of the group does, some amazing research. The other half of the research group, including myself, work here in the UK. And there's two different aspects to that work in the UK. The first aspect is shown on the left of your screen with these two images here. We do a lot of field work with the local wildlife trust for Bedfordshire, Cambridgeshire and Northamptonshire. So we do lots of work on their nature reserves. And in particular, we look at a lot of stuff on UK butterflies and endangered butterflies, such as the Duke of Burgundy butterfly you can see on the bottom left of your screen there, which has had big declines. And we're basically trying to better understand their habitat requirements and help their conservation. And in recent years, we've been particularly interested in climate change and how we can better manage nature reserves for a changing climate. So the top left picture is of a butterfly bank. It's an earth bank, an artificial change to the topography, which we are trialing to see if they can act as sort of microclimate refuges. So as it gets really hot, will they produce shade and shelter for these different species of butterflies and other invertebrates as well? And then the second aspect of the work is linked to the Museum of Zoology. So following on from the public engagement project I used to work on, at the top right, we have our biggest specimen on display at the University Museum of Zoology. That's our fin whale skeleton, 21 meters long. And this museum is obviously a fantastic resource to have at the university. It's brilliant public engagement, but it's also an amazing resource for historical information. So as well as these huge specimens like the fin whale, which is our biggest, we estimate we have over 1 million insect specimens behind the scenes in the storerooms. So I'm looking, as part of my PhD, I'm looking at the historical label data and records, trying to catalog them and see how the historical data they have can teach us about past population change. Obviously, a lot of that is decline, but also some increases as well. So for the majority of this talk, I'm going to be splitting it into roughly two parts. The first section will discuss the modern conservation I'm doing on the Wildlife Trust reserves and butterfly banks. And then the second half will flip to the museum work, butterfly specimens of the past. And I'm going to talk to you a little bit about a specific example of a story that they can tell us and inform us about modern conservation. So let's first of all have a little look at modern fieldwork in the UK that we do as part of my research. So I'm working on something called the Banking on Butterflies project, which is a joint venture between the Insect Ecology Research Group and the Wildlife Trust for Bedfordshire, Cambridgeshire and Northamptonshire, on whose reserves I do my research, as I mentioned. And we're asking the question, can butterfly banks protect invertebrates from extreme weather events and rising regional temperatures? So why, in particular, are we specifically interested in butterflies? The first point might seem a little bit trivial, but they are very popular insects. So if you want to do a public engagement project and you want to get people on side with caring about insect conservation, they are a good one to start with. They're almost like a gateway insect. You get them interested in the butterflies and then you turn them to the dung beetles and the cockroaches later on, which I agree are incredibly important. But sometimes it helps people to be engaged with something like a butterfly first. But then the second and potentially more important reason is that they do have a complex life cycle. And I'm sure most everyone tuning in tonight will know this, but butterflies have distinct life stages. So you've got, this is a Duke of Burgundy again on your screen. We've got some small little eggs up in the top left and tiny caterpillars in the top right, eating and eating and eating away to become a big caterpillar at the bottom, undergoing complete metamorphosis, completely changing their body plan into the adult butterfly on the bottom left. Because they have these very distinct life stages, each life stage can actually have very specific different requirements. And that means that if there's a small change in the environment, it's likely one of these life stages will be impacted. And basically, that just means that butterflies are very sensitive to change. They can be early warning systems for something bad going on in the environment. If you see their numbers going down, it can tell you that something more generally worrying is going on. And that is why recorded butterfly declines are so worrying. So we have, since modern records, modern intensive surveys began from the 1970s, in the last 50 years, lost 80% of our, or 80% of our UK butterflies have declined in either abundance or distribution. And remember, I just said that's a kind of indicator for how the rest of the environmental world might be doing. So that's quite a worrying trend. On the right, this image is quite old. It's from State of UK, Britain's and Ireland's butterflies in 2006. It's every single row is a different species of butterfly, and if it's a red row to the left, it's a decline. If it's a green row to the right, it's an increase. You can just see there's far more decreases there. And we've got things like the wood white and high brown patillary as some of the worst declines. Why have they been declining? Well, historically, in this country, it's been a lot of habitat loss and fragmentation. A huge amount of our natural and semi-natural habitats have been converted to agriculture. But looking to the future, it is projected that climate change will start to become the biggest cause of biodiversity loss in the UK. So that's why we're interested in climate change. What are species going to do as things begin to warm up? Well, I already mentioned that butterflies can be very sensitive to change in their environment. Even a few degrees temperature change might make somewhere unsuitable for them. And some individuals, some species, are going to be able to cope by moving north up through the country. So obviously in the UK, it tends to be warmer in the south and colder up in Scotland. And so you might expect a distribution like this, where the red dots show, for example, this isn't real, but where a small tortoiseshell butterfly is currently found. So as things continue to warm up, you might get species spreading north through the country. And the distribution you might expect to move a bit like this. And it might actually get too warm for them in the south, so they could follow their suitable climate. But what if there is a barrier here? And remember, I said that species will suffer in this country because of past habitat loss and fragmentation. So this is a very real problem. There's not lots of linked up habitat in the UK, although lots of conservation organisations are trying to make that happen. So what can we do for species that can't easily move through the landscape? That is what the PhD research is looking at. This Banking on Butterflies project is looking at. How can we move help species that can't move? So this is a model. This isn't the real thing, of the butterfly banks that have been built as part of this project. And the idea is quite simple. You take what was initially a quite flat area of a nature reserve, say it was an ex-arable field, which has recently been purchased by the conservation organization, which might only have not much variation in temperature. So basically only one set temperature across the entire field. You then bring in a digger and you change the topography, make lots of banks with different slopes in shade and shelter. And hopefully this creates a more varied variety of microclimates for species to use. So if you are a very hot butterfly and you need to cool down, you might go on this cold, exposed, shaded slope here. If you're cold and you want to warm up, you go into the middle of this sunny, sheltered part of the bank here. It's not rocket science, but it can't be if it's something that people are going to be able to use more widely. We've decided on a giant E shape, get asked this a lot, because of the flat sides, we have slopes that face every direction of the compass. So we've got north, south, east, and west, and they are all easy to measure. We can tell what a north and south slope is very easily. Lots of butterfly banks are sometimes built in big S shapes, which are great, but it's difficult to figure out when the north bit of a bank becomes a south bit of a bank and an east bit of a bank with that kind of shape. And on the inside of the capital E prongs, we've got a lot of shelter, and on the outside, we don't. So it's quite a good shape, which is reasonably easy to build, easy to analyze, and has a lot of variation in shelter and shade, and hopefully variation in microclimates. This is what the real banks look like. So we've got a top-down drone shot of the banks on the left, and you can see there's a 10-meter scale bar there. The banks are about 15 meters long, 2 meters high. There's a picture of me doing a butterfly survey on the right. And as I said, we're hoping that this creates a whole different host of microclimates over the flat areas and the sloped areas. The reason they're very white is because this is just a very chalky earth in Bedfordshire where they're built. We've literally scraped off the top vegetation and piled the earth up into a pile, and that's the color it is. We're actually in the process of building some more, but originally 8 banks were built in total at 2 sites. So 2 sites in Bedfordshire, at Tottenham Quarry and at Pegston Hills. So this is a kind of mock-up example of what the Pegston Hills site looks like. And again, so there's 4 at each bank at each site. You'll notice that each of these banks is facing a different direction. So the prongs are facing north, south, east, west. Again, that's more of this maximizing variation. At any one point in the day, the sun will be shining on these banks in different ways, creating different arrays of shade and shelter, and we hope different microclimates. So as part of the PhD, before and after the banks were built, we put lots of little tiny data loggers, temperature recorders, all over the banks, on the flat areas, on the sloped areas, and away from the banks as well as controls. So we're seeing what impact the banks have had on temperature, but I'm also doing butterfly surveys, terrestrial invertebrate surveys, and ground flora plant surveys as well. So we're seeing what impact they have on temperature and what impact the banks have on species of plants and animals as a result, which is really interesting. But the main reason we're interested in the banks is how they might help species in the future when climates get even warmer, when extreme weather events get more common. What will they do then? And it's tricky to test that before those future temperatures arise. So how do we do that? Well, we took advantage of the extreme heat wave in July 19th, 2022. So I'm sure you'll remember this, but we got to over 40 degrees in England for the first time. And this really is a little snapshot of what future temperatures in the UK might look like. I know there's a news story going around of a predicted weather pattern in, I think it was 2050, and the temperatures from this day are strikingly similar to what that weather pattern could be. So the data we collected on this day is some of the first data that has ever looked at if you can artificially create microclimate refuges for Lepidoptera specifically, but also potentially for other invertebrates as well. So to test the impact of this event, we did some surveying. So when everyone on the news was saying, stay inside, it's really dangerous to go out today, it's way too hot, my supervisor said, go out in the midday heat and survey for butterflies to get some cool data, which we did, to be fair. And he did come with me as well. So this is Pegston again on your screen here. This is the site I was just showing you. And over the course of the day, we surveyed the entirety of the area that's highlighted. So we've got the 4 banks in the middle. The rest of that field is basically just long grass. And on the right-hand side of your screen, there's a scrubby wood border. And we just went back and forth, waving a butterfly net in front of us, getting to within 5 meters of everywhere on the site. And whenever we saw a butterfly, we recorded a few different things which are listed on your screen. So firstly, we recorded the species, then we recorded air temperature, and we tried to catch the butterflies in a net and take a body temperature reading. So we've got a very fine thermocouple probe, which you can feed through the netting of a butterfly net and touch to the body of a butterfly, take a body temperature reading, and then release it. So we're taking air and body temperature readings. And then we also did some behavioral readings. So was the butterfly in the shade when we first observed it? Was it within 5 meters of shelter? So 5 meters of a bank or the woody vegetation? Was it observed actively flying when we first saw it as well? We then also did a few different time periods for these surveys. We did a morning and afternoon survey to see if the temperature changed over the course of the day on that really hot day, and if that impacted behavior. So yes, we did that on July 19th, that extreme temperature day. but we also repeated the surveys on 5 subsequent days over 2 weeks in what we would term kind of normal temperature conditions, just to see if that extreme temperature day did have a big impact on the butterflies we were observing. And this is what we found. Just flag actually. So we got, over the course of all this recording, 6 days in total, we got about 926 butterflies. So even though it was just one hot event, we did get quite a lot of data. And on the right, we have the survey categories listed for you. So the ones I was mentioning, and in light and dark blue, cold morning, cold afternoon, that's our normal temperature days. And the temperatures next to them were the range of air temperatures that we recorded. And in the red, we've got hot morning, hot afternoon. That is the extreme temperature day from July 19th. And then if we have a look at the actual figure itself, on the y-axis, we have the percentage of butterflies during a survey which were observed in the shade, observed within 5 meters of shelter, and were observed flying. So first of all, just look at the observed in the shade. You'll notice that during the majority of the different survey categories, very few butterflies are in the shade. This makes sense. Butterflies are ectothermic. They rely on heat from their environment to warm up, to power their flight muscles, power their metabolism, and they want to be in the open to warm up. But get to the hot afternoon, this red bar on the end, you see that it flips to nearly 100% of the butterflies we saw were in the shade. The shelter category is very similar. Normally about 20% of butterflies were near a butterfly bank or near the woody vegetation. By the time of the hot afternoon, on that extreme temperature day, nearly 100% of the butterflies are seeking shelter, are in shade, shelter seeking shade. If we didn't look at the woody vegetation on the side of the field, the only reliable place within our survey area to find butterflies that afternoon was on the shaded slopes of the butterfly banks. I think we only found 2 butterflies in the grass itself. Normally, on all other surveys, we found at least kind of 30 to 50. So it was a striking difference. Then the final category, observed flying, we actually do get an increase in activity on the morning of July 19th. You'll see that the hot morning, by about 10 in the morning, it was already nearly 35 degrees. So it was like a extremely hot day on a normal summer. It'll still be a very hot day on a normal summer in the UK. That initial increase in temperature initially increased the activity, that the way in which the butterflies could heat up, and they were more active. But again, by the time you get to the afternoon of July 19th, that red bar's gone really, really small. The activity really rapidly drops off. So what we're seeing is when you get towards 40 degrees, you see a reduced activity, and instead butterflies are seeking out shade and shelter. Again, it's not rocket science, but it was really interesting to observe this, and it was a very strange feeling on that day. We made some other just interesting observations during that afternoon as well. In a few small square meter patches of shade, we found massive multi-species groups of butterflies and other insects. So maybe 2 meters squared, up to 9 species of butterflies huddled together. You can't see them that easily on these images, but there's actually, if you look at the bottom of the images, there's loads of hoverflies as well, and crane flies, but the arrows are pointing at some small and Essex skipper butterflies, which are right next to some common blues and some marbled whites. And I've never seen this before. It's a midsummer's day. There's nothing flying. The only things we can see are in very small patches of shade, all together, not moving. It was quite strange. And the body temperature data suggests that they were indeed using these patches to thermoregulate, to lower their body temperature because the environment was too hot. So if we look at this figure, the x-axis, we have air temperature, and the y-axis, we've got the body temperature of the butterflies, and that black horizontal line going through is a 1-to-1 line. So you can see that the dots are mainly above that line, which means the butterfly body temperatures are normally above air temperature. All the points in blue are again the normal temperature days, those 5 days of surveying after the really hot day, and the red dots are the really hot extreme temperature day. And I just want you to have a look at the blue trend line. If you look at it quite closely, you'll see that it is moving slightly up and away from the black 1-to-1 line. So under normal conditions, butterflies are trying to raise their body temperature above that of their environment, which we've already talked about. It makes sense. They rely on heat from their environment to warm up. But look at the red line. That is dipping back towards the 1-to-1 line. These butterflies are trying to cool down. And actually, you can see that on the hot afternoon, when things were between 35 to 40 degrees air temperature, we have the only instances where butterfly body temperature is lower than air temperature. So they were selecting shaded microclimates and shaded substrates to sit on to cool their body temperature below ambient. So it's a complete flip in their behavior. So just to conclude this first half of the presentation and the kind of modern research aspect of the PhD, the take-home message is really that the future high temperatures experienced on that day were quite striking. They were quite scary. Midsummer, nothing flying. It was really quite strange. Butterflies went from, after an initial increase in activity with a little bit of temperature rise, they then actually rapidly dropped off, seeking out shade and shelter to thermoregulate. That being said, it looks like simple management options, potentially building artificial banks, or maybe just putting woody scrub vegetation in amongst grassland, can provide shade and shelter and little microclimate refuges for species to see out the worst of the weather. It's obviously not the only, it won't solve everything, but it might be something that conservation managers can use in their repertoire to help against some of the negative impacts of climate change. What's next for the banks? We're going to continue to monitor them, and see how they change over time. In the top right, you've got what they look like when they were built. So this is a bank in Tottenham Quarry in Bedfordshire, completely bare. We didn't seed them at all. We wanted to see if species would just use them for their thermoregulation properties. But obviously, if they have plants growing on them, they might be more useful to many species. And this is the same bank on the bottom right, 2 years later on Tottenham Quarry. As I said, wasn't seeded at all. This is just natural recolonization of the seed and plants onto it over 2 years. So it's going to be exciting to see how much that changes. And this paper I've been talking to you about on the extreme heat, the paper's called Heatwave Predicts Shady Future for Insects, is available open access in Journal of Insect Conservation. I believe the link will be sent around to you after this talk as well. So that is the modern day research that we're doing, sort of like the present day looking to the future problems. Now I want to go back to the wildlife of the past. So looking at the specimens in the zoology department in Cambridge and the University Museum of Zoology. So as I said, this is an amazing resource, and the galleries at the museum were reopened to the public in 2018 after massive redevelopment. So if you do get the chance to go along, please do. It's completely free. It's not open on Monday, but it's open all other days. We estimate, so this is what the galleries look like. We estimate we've got about 6,000 to 7,000 specimens on display in the galleries from all walks of life in the animal kingdom. So from lots of obviously very big, impressive things. We've got lots of insects on display as well. But as I mentioned right at the start of the talk, this is only a small fraction of specimens that are actually stored on museum sites. So behind the scenes, we have lots of storerooms. This is the insect storeroom. And we think that even in this room alone, there's probably more than 1 million insect specimens behind the scenes. So they're stored there for many reasons, for conservation of the specimens themselves, for research. And we physically don't have space to put everything on display. That'd be quite cool, but that's not how our space works. We do occasionally rotate specimens out, but nevertheless, a huge amount is behind the scenes here. So on the left, you've got all of these cabinets on rollers, and all of those cabinets are filled with drawers, which you can see in the middle picture. And all of those drawers are filled with sometimes thousands, but often hundreds of different insect specimens. This is a drawer of large blue butterflies here on the right. If the person who originally collected these specimens has been good, each of these pinned butterflies, each of these pinned insects should have their own data label on that pin. So this could be more than 1 million historical data points of where and when species in this country, but also further abroad and the rest of the world, where they were found. It's a kind of historical database that is, as of yet, not very readily available. This is the last main collection in the Zoology Museum to be catalogued electronically. So we have a vague idea of what we know roughly that, we have this many butterflies, but we don't have any idea we don't have any idea. We don't have a transcription of what is on these data labels. So we don't know where and when a lot of these species were collected. So as part of the PhD, I have been trying to chip away at this. I would love to do all of the specimens, but there's 1 million there. I can't do that at a PhD. So I've focused on the UK butterflies, and I think I'm nearly there. So I'm about 2.5 years into the project for the PhD, and I was doing some of this work before on a public engagement project before the PhD. And I probably catalogued about 18,000 UK butterflies in our collection. I reckon we have somewhere around 20,000. So let's have a look at the data labels. This is what your average specimen looks like. And again, if the collection of the specimen was good, they should have recorded when and where the specimen was collected. And we can then use that data to compare with today and see how much things have changed. So here, if you look at the top right label, we've got a beautiful checkered skipper butterfly in the middle of the picture. On the top right, it says Castor Hangland's 3583. So Castor Hangland's the 30th of the 5th in 1883 is what that means. It's quite impressive for an old butterfly. So the Castor Hangland's is a site near Peterborough where this species used to be found quite regularly, but it can't be found there today. So instantly, this is an example of change which the museum collections store for us. The species held on in Scotland for quite a long time, and actually was quite recently reintroduced to Northamptonshire. But the locality of this species is one in which it is no longer found. So I'm hoping that this is just one specimen, one example. I'm hoping with these thousands of specimens we'll be cataloguing, making them available to people, we can extend trends back in time and see how things have declined or, maybe increased, and where and when they were lost from certain areas. There's also, as well as the label data, there's morphological data. So this is a beautiful swallowtail butterfly. This is actually a specimen that was caught in Cambridgeshire. And if we image our collection, then even more data could be gathered from it. And it's amazing. The Natural History Museum in London has done their Lepidoptera collection, their butterflies, and UK moths as well. And for example, you can, from an image, if you have a scale bar, you could then measure the wings, and you could see how their wing sizes changes over time and how it changes with their population size. So as a swallowtail butterfly's population declined, were they growing bigger or smaller wings and that kind of thing. So there's a lot of data you could get from these specimens. Yeah, I'm looking forward to studying the trends and looking at the morphological data, but I'm really proud of trying to catalogue this collection and put it online. This is a breakdown of what I've done to date. So on the x-axis, you've got all of these different columns of different species of butterfly that are catalogued in our butterfly collection, and you've got a number of specimens on the y-axis. So there's nearly 1,000 of, we'll probably get to over 1,000 for some of these individual butterflies. And the little red dotted line just sections off the top 10 most represented species in our collection. And even just looking at this is quite interesting, because you can begin to think, okay, so why were people collecting these 10 species more than others? If you look through the names, there's a lot of blue species there. Chalkhill blue, common blue, Adonis blue, silver-studded blue. We do have a collector who was particularly interested in these species, so that will bias it a bit towards them. But also, apparently, it's the same in the Natural History Museum. The blue butterflies, they're in a group called Lycaenids, apparently have lots of different interesting color morphs. And if you're a Victorian naturalist, those different color morphs are more valuable and rarer. So there's often a bias towards them. But if you also look, we've got swallowtail, large heath, and marsh fritillary really well represented in our collection. These are species that are like wet or heathland habitats. So we can begin to think, okay, so why are people looking at those in particular? And we'll come back to that at the end of the presentation as to why they might be looking at them. What I want to do now is change tack a little bit. I want to give you an example of the kind of stories that the historical collections can tell us. So I've given you a few, but I want to give you another specific example and how they can link to modern day conservation and kind of be relevant to today. And to do that, I'm going to focus on one particular naturalist, one Victorian wildlife collector that is represented in our collections. And that is a chap called Leonard Jennings. So here's a picture of Leonard Jennings here. He lived, as it says, from about 1800 to 1893, which is a great age, especially for back then. And he grew up in Cambridgeshire. So he lived for his early life in Bosham Hall, just north of Cambridge. And he had quite a religious upbringing. His father was a vicar in the local area. But he also had an interest in the natural world fostered from an early age. I believe it was an uncle of his who had quite an extensive natural history library, who would send lots of books to Jennings, and Jennings would spend lots of time in the countryside looking at wildlife and making recordings. In terms of his education, he went to Eton in 1813, and then he went on to Cambridge University in 1818. And again, the idea was he was going to follow his father's footsteps to study for the clergy to become a reverend in the local area. But it was a really good time at this period in history to be at Cambridge and be interested in wildlife. There was a professor called John Stevens Henslow who lectured on the natural world. He organized excursions, and there was a kind of hub of naturalists who were really interested in wildlife at Cambridge at this time. And it was through this interest that Jennings met other interested naturalists of the day. And chief among them, well, who might be most recognizable to us, was a young Charles Darwin. And Darwin he was a bit younger, so he joined Christ's College in Cambridge in 1828. He was also studying for the clergy. All of the Victorian naturalists were studying to become reverend, but he didn't want to be there. Darwin's father was worried that Darwin wouldn't really amount to much, so he said, "You should go to Christ. You should become a reverend and kind of make something of your life." Darwin just spent all of his time out in nature collecting beetles. He was very well known for this. So one of his friends drew this picture of Darwin riding his hobby. So he's riding a giant beetle there. It says, "Go it, Charlie." So he was clearly a very avid beetle collector. And in the Zoology Museum, we are very lucky to have Darwin's beetle collection from when he was a student at Christ's College. So made by Darwin before any of his kind of grand theories on evolution and natural selection, whilst he was studying as a student, ignoring his studies. So I really like it for that reason. So here we are then. We're at Cambridge. We've got Darwin and Jennings both going to lectures on natural history, going to excursions. They both got the same mentor, John Henslow, sharing the enjoyment of the natural world. So you would maybe think that potentially they were going to become firm friends. Well, no. At first, they really didn't like each other and they were rivals. So this is an early letter we have from Darwin talking to his cousin about Jennings. You'll see my name in Stephen's latest number. I'm glad of it, even if it's just to smite Mr. Jennings. So great that I've been published, but I'm mainly just happy about the fact that Jennings wasn't published, and I'm going to rub it in his face. I really like this, because this is maybe a side of Darwin we don't think about or see. But initially, they were competitive. That being said, they did then form a relationship. It seems that they actually got to know each other and became good friends. This is Darwin talking about Jennings later. At first, I disliked him from his somewhat grim and sarcastic expression, and it is not often that a first impression is lost, but I was completely mistaken and found him very kind-hearted, pleasant, with a good stock of humour. So they're friends now. That's great. They can go on beetle collecting expeditions together, and they did. This is from our museum collection. This is a beetleLIVE catalogued, a black night runner beetle, I believe. And these are the two data labels that were on it. So it says near Cambridge, see Darwin, so Charles Darwin. Just to say, this is a terrible data label. It's not got a date. Near Cambridge could be anywhere. So not the best label for Darwin, but still quite cool. And X collection, Leonard Jennings. So at one point, this beetle was in both of their collections, maybe collected by Darwin and then given to Jennings. So they were collecting together and exchanging beetles. One of my favorite stories about Darwin, you might have come across this before, but is actually one of his accounts of beetle collecting, which he wrote to Jennings in a letter. So reportedly, Darwin had been out collecting beetles for some time. He'd already found two, like the ones you can see on your screen. And he was holding one in each hand. But at that point, he saw this beetle, which is a crucifix ground beetle. It's very rare today. It was quite rare in Darwin's day. So he really wanted to get it, but his hands were full. So what was he to do? Well, he tells Jennings, in despair, I gently seized one of the beetles between my teeth, when to my unspeakable disgust and pain, the little inconsiderate beast squirted his acid down my throat, and I lost both beetles and the crucifix ground beetle. So again, I really like this because we think about Darwin as this great kind of theorist. At this point, he was a student not doing his studies, literally putting beetles in his mouth. And what we think happened, if I just go back a slide, we think one of these original beetles was probably a bombardier beetle, and they have a protective mechanism where they can squirt this really hot, foul-tasting liquid as a protection, and it clearly worked because Darwin spat it out and all the beetles got away. So I basically told you that because I find that quite interesting. I love the links the museum has to important naturalists of the day. But that's the bit of the story that's less famous. Then comes 1831. Darwin had just finished his studies in Cambridge, and Captain Robert Fitzroy is looking for a naturalist companion on the Beagle to accompany on a voyage around the world to map some coastlines. They need a kind of naturalist companion to help with that. Henslow and Jennings were more senior, so they were actually asked first, but they had a mixture of young families and new jobs as reverends and things to attend to. So they turned down the job and they suggested Darwin as a replacement. So if either of those men had taken on that position, Darwin may not have traveled the world, may not have gone to the Galapagos, and may not have formulated his theories on natural selection and evolution by natural selection. So it's interesting to think that these individuals were Jennings and Henslow on the fringes of this really important part of history. So years later, after Darwin had published his theories on natural selection, Jennings was asked about his decision to not go on the Beagle voyage. And I think this is quite a nice response. He says he regretted his unimaginative decision, but that no better man than Darwin could have been chosen. So perhaps Jennings wouldn't have. He was a reverend after all. Perhaps he wouldn't have ever thought of the theories that Darwin did. We're left then with Jennings not going on the Beagle voyage. What did he do instead? He went on a voyage of instead of going on the voyage of discovery around the world, he actually never once went abroad. He stayed in Cambridgeshire for about 30 years. He created the Cambridge Philosophical Society Museum with Henslow. So this was a society for academics of the day who could discuss topics and their research together. And those museum specimens in 1865 were donated to the Museum of Zoology in Cambridge, where I work. So they were really important. They formed kind of the nucleus of our collections, which have been added to since then. This is an image of what the old museum looks like back in the day before the refurbishment, kind of like I guess it is a bit more like a Victorian trophy cabinet. And then behind the scenes, these are some of Jennings' specimens. So these are still in the drawers today. These are some of his Hymenoptera, so he's got his bees and his wasps here. And quite a lot of these have historical data labels. But probably even more important than the specimens themselves are Jennings' notebooks. So I mentioned that Jennings lived in Cambridgeshire for nearly 30 years. And during that time, he made lots of wildlife recordings. So he was working as a reverend and he had lots of free time on his hands to go out into wildlife. And he, in his notebooks, made a recording of every single species that he and his friends saw in the county. So these were also donated to the Zoology Museum. We've got 4 volumes. We've got 3 looking at the insects and arthropods, and 1 volume looking at the larger animals with backbones. And I think it's also got mollusks in as well. This is quite a rare resource. So normally collectors just record a few groups or species that they are particularly interested in, and from locations perhaps where they happen to go on holiday or something like that. It's really rare to do what Jennings done and have everything listed that he could find from one place in a long period of time. So what this means is, of course, he will have missed things, but we have a near comprehensive list of species that lived in the county 200 years ago, and we can compare it to what we see around us today and how much things have changed. So I want to show you, there's a very long-winded way of showing you some of the stories that the past specimens can tell us. And we can have a look at 2 butterfly examples here. So we've got the swallowtail butterfly I've already mentioned, which is really well represented in our collections. And we've got the large copper butterfly here. And let's have a look at what Jennings' notebooks say from around 1820 to 1841, that time. So found in the greatest plenty throughout the fens between Ely and Cambridge, and not uncommon in Cambridgeshire. This is really striking because both of these species can no longer be found in Cambridgeshire. The swallowtail butterfly, it can be found in Norfolk, but that's the only place it remains in the UK because it can be found in the Norfolk Broads, but no longer in Cambridgeshire. The large copper has been lost from the country. You can still find it in mainland Europe, but you can't find it in the UK anymore. So you build up this picture from these past specimens of how things have changed. You can then think, okay, so why have they changed? Well, these are both wetland specialists. And since Jennings' time, and actually about 1851, so only a few years after he moved away from Cambridgeshire, after those 30 years of recordings, the last wetlands in this area of the country were drained. Whittlesea Mere, last of the large lakes in this area, was finally drained. And without the wetland habitat, these species followed suit. So I think this is a powerful example of how museum specimens and notebooks can tell us of how things have changed, what we've lost, and why. I've done work at the museum where we've been showing people museum specimens that used to be found in large numbers where they live, but in quite a short period of time have now gone from being in the greatest plenty to not there at all. That is interesting in itself, but I think even better, this can then feed into modern conservation and provide a rationale and backing for modern conservation initiatives and getting people engaged with wildlife that is still around them today and how they can help. So, for example, the Wildlife Trust for Bedfordshire, Cambridgeshire, and Northamptonshire are working on something called the Great Fen. The blue outline on your map here is meant to be the old extent of the Fen Basin in southeast England. So, over the last, even it extends quite far back in time, but the last few hundred, maybe even 500 years, the fenlands have been progressively drained, and more than 99% of wet fenlands have been lost from this country. So that's what the blue outline used to be. The little red outline there, is the planned area for the Great Fen. So it looks like a drop in the ocean, but it's actually a really big site. It's what's called a living landscape, 3,700 hectares. The aim is to re-wet this landscape and to create biodiverse wetlands in the area once again. And interestingly, two old fenland fragments still survive. So the plan is to link them back up, as well as creating more wet fenland habitat as well. So link them up for the first time in 150 years. That'd be really cool. And another really exciting thing about the Great Fen is that the reason it was drained in the first place was to make space for farms. The project is working with the farmers in the area to test new forms of crops that can be grown in wet soils. So it's going to be good for biodiversity, but also hopefully still a productive land in that way as well. So that's really exciting. And if enough suitable habitat can be regained, this biodiverse fenland will support the species that still exist, but hopefully species like the swallowtail and large copper might be able to come back. Swallowtail is still in Norfolk. It's not too far away. Potentially the large copper could be brought back as well. In the past, reintroduction attempts of both those species have been attempted, but the habitat hasn't been there, hasn't been enough for them. So build enough habitat, hopefully these species will come. And just to flag it, it's of course it's not just the Great Fen, it's a really good example, but there are wildlife trusts all across the UK, loads of conservation organisations across the UK. Of course, things like the talks that we're doing at entoLIVE tonight are linked to loads of great organisations. And this is just a map of the local three counties, the wildlife trust that I'm partnered with. And 95% of the population live within 5 miles of a wildlife trust nature reserve, which are free to visit. All the black dots on that figure, over 100 nature reserves. So the Butterflies Through Time project I was doing at the museum was, again, it was using these stories from historical naturalists and this history of decline, but linking them to projects that are happening today, which are having a positive impact, and ways anyone can get involved, just highlighting the green spaces, the conservation going on around them, which everyone can visit and get involved with where they live. And with that, I just want to say thank you to everyone at the Wildlife Trust who I've worked with at the Zoology Museum, and every one of the funders who have helped with the research over the past few years. And yeah, I'll very happily take questions. So thank you.